So today's lesson is continuing our study of circles and looking at the difference between a central angle and an inscribed angle. So we're going to pick up on a couple of things that you talked about yesterday, where we looked at things like major and minor arcs, and we're going to look at those degree measures with circles. So one of the key things to remember as we start off here is that the number of degrees in a circle is 360 degrees. Okay, and you keep that in the back of your mind as you go through things today. Things should help here. So in the picture that you see here on the screen, you have a central angle, some vocabulary terms: central angle, major arc, minor arc. We know a minor arc is used with 2 letters and written like that, where a major arc is using those 3 letters. And you notice there's like that little curve on the top to denote the arc there. So let's talk about the central angle. So what makes this a central angle? Well, not too crazy here, but the angle, its vertex is at the center of the circle. So anytime you see this circle here, or something like this, and that dot is right in the center of the circle, that's going to be a central angle. As we go through and look at, we want to talk about what are the measurements for these types of situations. So if I look at the measure of MN, okay, that's this arc that's located out here, okay, I notice, it's 80 degrees, so the central angle is the exact same as the arc measure that it goes with. So this would be 80 degrees. Now I have MPN. So kind of tracing that around from this part of the circle. Well, if I'm looking at that, how much do I have here? Well, I know the whole circle is 360, and I know this part here was 80, so 360 minus 80 would give me 280 degrees. And last but not least, we see arc PMN here. And one of the things that I put in here, a little question, is what is this green line? Well, the green line is the diameter, and that's something you want to look for in maybe one of these problems, just to kind of help yourself out. And what does it do to the circle? It splits it into a semicircle, into 2 halves. So if we know this is 80 on the left-hand side here, we know that that part on the right would be 100 degrees. So we got 180 here, and then this part above here on the top would also be 180. So PM from P to M to N is just going to be that half of a circle there, so that would be 180 degrees as well. So here's some practice finding measure of arcs. So once again, if we look at GE, we are going to go from G to E, so that means I need to just basically include both of these arcs together. So the 40 degree arc plus the 40 degree arc plus the 80 degree arc would give me 120 degrees. Okay, from G, E, and F, okay, so if I'm looking at G, E, and F, I'm going to follow those letters in the order that I see them, so I'm going to go G to E to F. So I'm looking at this part. Well, now I need to include the 40 to 80, and now the 110. So take the answer that we had in A here, and just tack down another 110 degrees, and you'll see that my answer comes out to be now 230 degrees. Finally, I look at GF. So I got GF here, and GF is that last part here, and I've already found the other parts, so I can just take 360 and subtract off what I already know from the previous answer here, and that will give me the last part here. So 360 minus 230 would give me 130 degrees. Also remember, minor arc, it's under 180 degrees, so we use 2 letters. So there's also kind of a hint there for you to kind of help you out. So take a look here, find the measures of each arc of circle A. So A is in the center, so I have some central angles here. So BD, once again from B all the way over to D. Alright, so I'm going to add those two together. So 83 and 42 added together should come out to be 125. If I go BE, I'm not going to continue to go. I'm not going to go like this way that I'm drawing. Now this is where you got to remember the difference between major arc and minor arc. It's two letters here, so it has to be the minor arc, the smaller distance. So if I look at all of that, there I've got 42, 45, 53, and 83. I'm going to add those all together and subtract from 360. So 42 plus 45 plus 53 plus 83 is 223. And 360 minus that is 137. Last but not least, we're going to do BED here. So if I look at BED now, BED is going to start here, B, go to E, and continue all the way to D. So now I'm going to add that part of BE that we just had, and then I'm also going to add the 45 and the 53 degree measure. So 137 plus 45 plus 53, and our answer there should be 235. So once again, remember, 3 letters is a major arc. That's over 180 degrees. 2 letters is a minor arc. That's under 180 degrees as we take a look. So once again, these are all the central angle ideas that we have to work with, and using those ideas of major and minor arcs. So next we'll talk about inscribed angles. So what's an inscribed angle? An inscribed angle is a little different. If you notice here, the inscribed angle, when I look at the inscribed angle, its vertex is on the circle. When I look at a central angle, it's in the center of the circle. So that's kind of the difference between the two. What you see here in blue here, we describe this as the intercepted arc. Okay, that's this blue portion that's here. We call that the arc of the inscribed angle. Okay, so the inscribed angle here, if you take a look, its vertex is on the circle. Okay, where the central angle, its vertex, like we said, is inside the circle. Okay, so one of the things we'll talk about is what's the difference in the angle measure. Here, on the right, when we saw an angle measure, we had something like, if we said this was 80 degrees, we knew that the arc was the same. These two were equal to each other. If I say that the angle here is 80 degrees, is the arc the same measurement? Okay, so a little picture here on the right that we're going to kind of go through and talk a little bit of this, have a little discussion about, is if I take a look at this measurement, it says in the figure at the right, one of the inscribed angles contains the center of the circle. What's the relationship between angle 1 and angle 2? Well, we got to look at this. If I go from B to P and I go from A to P, what are those? Those are radii of the circle. Okay, that's a radius. Each one of those that I highlighted is a radius. So what happens here in this triangle here, this whole triangle here that I'm going to highlight in purple here, this is an isosceles triangle. Okay, so it's an isosceles triangle. So if it's an isosceles triangle, that means that these two angles down here are going to be equal. Now, if you look at it from this perspective, I'm going to just draw this here. This little triangle right here, if I take this and I rotate this, Okay, that's kind of like the triangle that we have there. If we take a look and rotate it around here, we'll notice that the base angles are the same in the isosceles triangle. So angle 1 and angle 2, okay, angle 1 equals angle 2, okay? And now 3 says it's an exterior angle of the triangle. What's the relationship amongst 1, 2, and 3? In number 2, one of the things that in geometry that we know is if I take the measure of angle 1 and I add it to angle 2, it's equal to the measure of angle 3. And you might be like, what is that? Okay, that doesn't maybe make the most sense. So we're going to kind of fill out the table here below. Remember that 1 and 2 are the same. So if 1 is 20 degrees, I also know that 2 would be 20 degrees. That would then make, add them together, 1 plus 2 then would be 40. Okay, and the arc would make angle 3 40 degrees. That would make arc AC 40 degrees. Now why would arc AC be 40 degrees? Because this angle here that we're highlighting in green, number 3, that is the central angle that goes with this arc here that I've highlighted. Okay, so angle 3 and arc AC are always going to be equal to each other. Okay, alright, so we can kind of fill out the rest of the table below and get an idea here. If angle 1 is 30 degrees, 30 plus 30 would give me 60, and that arc would also be 60. If it's 40 degrees for angle 1, angle 2 is going to be 40. Add them together to give you angle 3, that would be 80 degrees, and the arc would be the same. In general, down at the bottom here, finishing off the last one, it would be x. If it's x degrees, it would be x plus x, so it would be 2 times x. And it would just be 2x. Now the interesting part here is at the very end, that when we talk about this, so I'm going to take a look at this picture again. What I'm going to highlight here is A to V and V to C is an inscribed angle. What's highlighted in blue is an inscribed angle. What is highlighted in green is a central angle. So the central angle is working off of the same arc measure. Okay? So if I take a look down here, okay, angle 1 is an inscribed angle. So when the angle was 20 degrees, the arc measure was 40 degrees. If it was 30, it became 60, 40, and 80. In general, if you know what the inscribed angle is, the arc measure is going to be double that. Okay? So just kind of to recap here, if this arc measure is 40 degrees out here in yellow, angle 1 in this little picture here of the triangle has to be 20 degrees. That has to be 20 in there. Okay? So the relationship between the inscribed angle and the central angle is that the angle, okay, you take the angle times 2, you'll find the measure of the arc. Okay, what's written here is saying that the angle is half the arc. It's the same way. But that might be something that you want to write down. Okay, that the angle is angle times 2 would give you the arc. So if you look in the example down here, down below, you'll notice that we have a right angle here pictured, and then asking what's the arc measure. So the arc measure here would be 180 degrees, because it would be double the 90-degree angle. Okay, so this arc measure down here would be 180. In part B, you are given 115, so then the blue arc would be 230. It would be double that. Okay, if you look at part C, the arc out here is 100, but that means I need to find the angle back here in the center. So what's this angle here? This angle then would be half of it, so it would just be 50 degrees. That would be my arc measure. Alright, so some central angle, inscribed angle practice here. So if I see that my angle, okay, I'm trying to find the measure of BAC. So that angle that I have here, that's this inscribed angle right here. Okay, so this one is a kind of a test to see if we can put together a bunch of these things. So if I take a look, the angle that they gave me, the central angle is 132. That means that the arc is also 132. But I'm trying to find that angle back there, so this arc that's on the outside here is only going to be half as big. So therefore I need to take 132 and divide it by 2 and cut it in half. So doing that, that's going to show me that that angle is 66 degrees. So if you look in the picture at the right over here, you're going to have, once again, an angle here. This angle is 28 degrees. This is the inscribed angle, so I need to find here the arc that's out here from B to C. So all I'm going to do is I'm going to take that 28 degree angle here, and I'm going to take 28 degrees, and I'm going to multiply that by 2, and I'm going to double that, and that's going to give me 56 degrees. Okay? Here's some other examples. We'll go back to this in a moment. If arc AC here, we want to find arc AC. If you know the angle here is 70, all I need to do is to multiply that by 2, and I will find that arc down there, which is 140 degrees. Okay? Down here at the bottom, arc ABC is 196. If I want to find that angle right there, I want to take 196 and divide it by 2. And doing that, it's going to tell me that that angle right there is 98 degrees. Okay? So here's some examples of knowing the arc or knowing the inscribed angle and then kind of working from there. The last thing that we want to talk about is what happens when two inscribed angles share the same arc. So I have angle X out here in green and angle Y that I've highlighted in yellow, and they both happen to share the exact same arc. So when that happens, both X and Y, angle X is going to be equal to the measure of what angle Y is. So in this case, X is equal to Y, which we would take 110 and divide it by 2, and you'd get 55 degrees. So this is when you see something that looks like that. So in this picture here, there's a bunch of inscribed angles. It says B, angle B right here, is 44 degrees. Okay? So this angle right here that we're talking about, right here in the center, is 44 degrees. Now, that makes the arc that's out here, that makes this arc out here 88 degrees. Okay? It says, well, what's the measure of angle C? Well, angle C is this angle right here. Well, notice that these arcs end up at the same point, so that means that this one is also going to be 44 degrees as well. So those are going to be the same. Finally, one little thing. If you happen to see an inscribed angle that, like this, and it goes through the diameter of the circle, this is kind of a unique one because we know that the whole, this part here would be that semicircle value. That would be 180 degrees here. We would know that the green arc out here would be 180. Okay, so this arc here would be 180 degrees. The angle down here then would be half of that, would be 90. So in this case, the angle is 90 degrees, and then we just set that equal to 2x divide by 2, and we found that x is 45 degrees. So, if you get a chance, go back, take a look. To summarize, we have central angles, where their center of the angle is on the circle, at the center of the circle, and whatever its arc measure, it's the same as the central angle here. You can kind of see that as I'm starring that. We have inscribed angles here, and its vertex is on the circle, but if you notice, it's the relationship between its angle and its arc measure here is 1/2. Okay, so that the angle is 1/2 of what the blue arc is. So if you got questions, feel free, let us know. Play back the video, take a look, and have a great day.